Welcome to this explainer. Look, if you work in tech, you already know that keeping applications running smoothly can sometimes feel exactly like trying to change the tires on a car while it's going 70 miles an hour down the highway, right? It's intense. Today, we're taking a massive DevOps cheat sheet, which is literally a survival guide for modern engineers, and we're distilling it down to one laser-focused concept: exactly how 3 specific methods fix errors. We're going to transform a sprawling, giant reference document into a streamlined, actionable battle plan.
Picture this. It's 2 a.m. Your phone is just buzzing relentlessly off the nightstand. You pull open your laptop, squinting at the bright screen, and stare at a terminal that is just a wall of red text. A deployment failed, and users are getting error pages. So how do you react? Are you scrambling through logs, trying to blindly patch the leak? Or do you have an automated system that's already rolling back the damage while it alerts your team? Well, today we are choosing the proactive route.
Okay, here's our roadmap for transitioning from reactive firefighting to proactive error management. We'll start with the inevitability of errors. Then we'll cover Method 1, code-level tracking, Method 2, automated log alerts, Method 3, container deployment rollbacks, and finally, building your safety net.
Let's jump right in. Section 1. The inevitability of errors, from micro to macro.
First things first, we just have to acknowledge a fundamental truth from our source material. Errors are guaranteed to happen. It's a certainty. Hardware fails, memory leaks happen, and weird edge cases completely sneak past testing. The issue isn't really the existence of the error, it's the scale of the impact that we need to aggressively manage, because errors can span from a single micro-level line of failing Python code all the way up to a massive macro-level container orchestration collapse that takes down your entire platform. Today, we're going to trace an errors escalation from the tiniest code snippet all the way up to the infrastructure level.
Moving to Method 1, code-level tracking. What is really cool about this first method is how we catch a bug right at the source, long before it has the chance to snowball into a system-wide crash. We're starting inside the application itself. Think about a risky mathematical operation. You might have a raw, unhandled Python zero division error, the kind of basic math bug that will literally halt a process dead in its tracks. But if you look at the cleanly handled exception derived from the source's Python section, we fix it by integrating the Sentry SDK. We monitor the failure without actually destroying the user experience.
So let's break down the exact recipe for this Python safety net. It's super straightforward. First, you import the Sentry SDK. Second, you initialize it using your project-specific key, or DSN. Third, and this is crucial, instead of just blindly running the dangerous calculation, you wrap that risky code in a try block. Fourth, catch the specific error, like our zero division error. And finally, pass that error object to capture exception. Boom, the app survives, it doesn't crash, and your dev team automatically gets a highly detailed error report. Win-win.
All right, Method 2, automated log alerts.
Okay, but what if the error isn't a simple Python exception? What if it slips past your code and starts writing fatal warnings directly to your system logs? To handle those system-level headaches, the source material brings in our second superpower, shell scripting. The cheat sheet has this massive toolkit of Linux commands, but it zeroes in on script 15, which is entirely dedicated to automating error handling and alerts using command line tools. Let's look at how a brilliant, simple 3-step bash script builds this second method. Step 1. The script uses grep to scan your log files, say /var log/myapp.log, for any sign of the word error. Step 2. It quickly formats a JSON payload. And Step 3. It uses the curl networking command to instantly post that payload to a Slack webhook. The payload itself is simple, error found in logs, but the result is huge. The exact second grep spots an issue, this alert hits your team's communication channel. Think about what that means in practice. You aren't waiting around for an angry user to complain on social media. Your own system is actively tapping you on the shoulder. Everyone is kept in the loop immediately.
Which brings us to Method 3, container deployment rollbacks.
Let's talk worst-case scenario. It's not a code exception, it's not a log warning, an entire deployment fails and the whole application goes offline. Following this automated rollback timeline from our source material, at time 0, a script checks the deployment's exit status. If it detects a failure, a non-zero status, it doesn't wait for a human to intervene. Exactly 1 second later, it runs Docker compose down to kill the failing environment. 5 seconds later, it pulls the previous stable Docker image.
By 15 seconds in, it runs Docker Compose up -d, and your previous working version is fully back online. That outage, it lasted seconds, literally, not hours.
But hey, maybe you aren't just running simple Docker containers. Maybe you're managing a massive, enterprise-grade Kubernetes environment. The cheat sheet has a solution for that too. Argo CD. Argo CD uses a GitOps philosophy. That basically means your Git repository acts as the single, absolute source of truth for your entire infrastructure state.
If an enterprise deployment tanks, Argo CD gives you 3 commands to get control back fast. First, you check your application's health with Argo CD app health. If things look bad, you dig into the pods with kubectl logs. And if you absolutely need to bail out, you just run Argo CD app rollback targeting a previous, stable revision. That right there is the ultimate infrastructure-level safety net, giving you granular control to restore service.
Bringing it all together now. Section 5. Building your safety net.
We've covered the micro, the system, and the macro. Honestly, you might want to screenshot this summary framework because it perfectly maps out our comprehensive defense strategy. Method 1 targets the source code using Python and the Sentry SDK. Method 2 targets system-level logs and alerts using Bash, grep, and curl. And Method 3 targets infrastructure-level containers with Docker and Argo CD. When you combine code, system, and infrastructure methods like this, you create an absolute fortress of a DevOps workflow.
There's a quote here that really hits the nail on the head. In DevOps, we don't just fix errors, we automate their resolution. That captures the true core philosophy of our explainer today. True reliability doesn't come from being the fastest person typing commands at 2 a.m. It comes from building systems that can literally heal themselves. We aren't just fixing things, we're engineering their automatic resolution.
So, I will leave you with this final question to chew on. Take a hard look at your own pipelines, your own code bases, and your own server logs. Are you constantly acting as a reactive firefighter, or have you built a proactive safety net? Apply these 3 methods from today's explainer, and I promise you, you can automate away your next 2 a.m. server crash. Thanks so much for joining me. Keep building, keep automating, and I'll catch you next time.